Let's take a look at a problem from your lab assignment, section 5.3. It says use part 1 of the fundamental theorem of calculus to find the derivative of the function, this is capital G of x, is equal to the integral of x, the integral of cosine squared of 6t dt, and we're taking the limits from x to 3. So again, the fundamental theorem of calculus tells us that the derivative of g of x is going to be the original function f evaluated at the variable x. So g prime of x is equal to little f of x is restating the fundamental theorem of calculus. Now, our x is not at the top limit like it says here. Instead, it's in the bottom limit. And so what we want to do is we want to put that x up to the top limit, which means we need to switch the values around. So if you have an integral from a to b, or from b to a of f of x dx, and that's equal to capital A, then switching the limits will give you basically the same thing, except you're going to generate a negative sign. You can think of this as instead of going from left to right, you're going from right to left, and so you're going to be accumulating negative signs. So therefore, our original integral, the cosine squared of 6t dt from x to 3, is equal to the integral of cosine squared of 6t dt from 3 to x with a negative in front. And so if we let f of t equal to the function inside of the integral, the integrand, then this is going to give us our f function, and our g prime, our little g prime, the derivative of little g prime is little f prime. But if we switch the order, they define that as capital G, then the derivative of that is the same as the f, which is cosine of square root of 6t. And so we want to replace the t with the x, and we also want to throw in the negative sign in front of that because of the order of the limits of integration. Okay, so basically the trick is that if your x is in the bottom of the limit, the lower limit, then you have to put a negative sign outside of that to make it go up to the top limit. And now once it's in the top limit, then you do the fundamental theorem of calculus, and then your answer is essentially going to be the same, except it has an extra negative sign. Okay, hope that helps.